Hello and welcome to this Python tutorial. Today I'm super excited because we're going to deal with a very powerful classifier. You're going to see how it will make a terrific job at classifying our users in the social network and how it will manage to catch those, rebellious users that made our dataset not linearly separable. That's what you need to understand. Our dataset is not linearly separable. That means that we cannot separate the two classes of users in our dataset by a straight line. And so we need more powerful classifiers to overcome this nonlinear separability of the users in our dataset. And we are going to do this with Kernel SVM, and I can't wait to show you the results. So here first, let's quickly set the right folder as working directory. So we'll go to File Explorer. Here I'm on my desktop, so I'll go to my Machine Learning AZ folder, Part 3 Classification, and Kernel SVM. That's the right folder. Make sure it has the social network ads CSV file, and if that's the case, you just need to click on this little button here to set this folder as working directory, and you're ready to go. Okay, so what we're going to do right now is we're going to take our classification template that we made in the logistic regression section, a template where we only need to create our classifier and then everything is ready. Once we create the classifier, then we can get a nice coffee, sit comfortably in our chair and watch the results. So let's take all this from here to the bottom, that is everything, copy, and let's paste this template in Kernel SVM. All right. So a quick reminder, this is a data preprocessing step. This is where we create our classifier. Here we predict the test set results. Here we make the confusion matrix to look at the number of incorrect predictions our classifier will make on the test set. And last but not least, my favorite part, visualizing the results. So we're going to visualize two results, the training set results and the test set results. Okay, so let's do this. We're going to start by doing the preprocessing step. So we'll do it all in once. We're going to select this and press Command or Control plus Enter to execute. All good. As you can see, the code executed properly. Everything is fine. We can go to Variable Explorer to look at our data set here, X-train and Y-train for the training set, and X-test and Y-test for the test set. This is the dependent variable. This is the matrix of features. Everything looks great. We can have a quick look if you want to X-train. As you can see, X-train is scaled. Everything looks great. We are ready to move on to the next step, which is to create our Kernel SVM classifier. So let's do this. As usual, it's going to be easy. We're just going to use scikit-learn to import the corresponding class for Kernel SVM. You're going to see that it's almost the same as SVM. And then we will create an object of this class, which will be the classifier object, and then we will fit this classifier object to our training set. So let's do this. We're going to remove this comment, which was just here for the template. So create your classifier here. Okay, and now let's create the classifier. So we're going to go to scikit-learn and import SVC. So let's do this from sklearn.svm import SVC. Okay. Next, we create our classifier. Classifier equals SVC. Now parenthesis. But before we input the parameters, let's have a look. So we're going to inspect SVC. And to do this, we're going to do Command or Control plus I to inspect SVC. So here we have some information, but what we're mostly interested in are the parameters to see what we have to input. So let's see. Okay, the first parameter is a penalty parameter. We're going to talk about that at the end of the classification part to, improve our model using some penalty parameters or using some regularization techniques. But for now, let's focus on the model itself and get the essential parameters. And speaking of essential parameters, there is one, the kernel. Remember when we used SVM, we used a linear kernel. which made our SVM classifier a linear one. Remember, we had a straight line separating the two classes of users. And here we're going to go a step forward because we're going to use a more sophisticated kernel, which will be the RBF kernel, which is like a Gaussian kernel. So we're going to use this kernel to elevate our data in a new dimension so that in this new dimension, our data can be linearly separable and separated by a hyperplane. And then we project back to the two dimensions to get the kernel SVM separator. So yes, we're definitely going to input the kernel parameter. So let's do this. Kernel here equal. So what is it going to be? It's going to be the RBF kernel, which is, by the way, as you can see, the default kernel. Actually, you know, when we talk about SVM in Python, it's by default kernel SVM. But commonly when we talk about SVM, it's the linear SVM. So since it's a default, we don't really have to specify this, but we do this, of course, to remind us that it's a Gaussian kernel. So comma, and then the next parameter. Okay, then what do we have next? Degree. Okay, so that's the degree of the polynomial kernel function. If we choose a polynomial kernel, you can try that yourself. You're going to get very interesting results as well. But here we're focusing on the Gaussian kernel, which is the most popular kernel. So we don't need to do this. Gamma, same for gamma. We will play with the gamma parameter to improve our model. But we don't really need to use it because without a gamma, you're going to see that our kernel SVM will do an awesome job. And so that's it. So we have the essential parameter, that's the kernel parameter. And then we're just going to add a random state parameter, It's a parameter that is, I think, yeah, random state here. Random state is here because the kernel SVM algorithm is based on random factors. So we want to use a random state here to all get the same results. And so we're going to input random state equals 0. And that's it. Our kernel SVM classifier is ready. How easy was it to do this? So that's pretty cool. So with this line, we created the classifier kernel SVM object. And now we need to fit this object to our training set so that our kernel SVM algorithm can learn the data of our training set to learn how to classify the users of the social network. So let's do this. We're gonna take our classifier here and then apply the fit method, which is here, fit, to the training set. And so we need to input the matrix of independent variables of our training set xtrain and the dependent variable vector of our training set ytrain. That's how we have to do it in Python. And that's done. With this line, our kernel SVM classifier will be fitted to the training set. So let's do this. Let's select this and press Command or Control plus Enter to execute. And here we are. Perfect. As you can see, the code executed properly. Here we have all the default parameters that were selected by default in this classifier here because we didn't specify them, but that's fine. Everything is all good. So now that our classifier is ready, let's predict the test set results. So let's just do this and press Command or Control plus Enter to execute. Here we go. ypred is ready. Let's have a look. Variable Explorer, ypred, and here is our vector of predictions. So let's compare it with ytest for fun. Here is ytest and here is ypred. So this is the truth. This is the predictions. So let's have a look. We can see already that everything looks, correctly predicted. We have all the zeros here from 0 to 6. Same here from 0 to 6. A 1 here in 7, that means that the 7th user of the social network in our test set bought the SUV, and our classifier predicted that this user would buy this SUV. Same for the 8th user. The 8th user didn't buy the SUV, and our classifier predicted that the 8th user didn't buy the SUV. Great again. But let's not celebrate victory yet. We have one incorrect prediction. Well, no model is perfect. Actually, there is one saying in machine learning saying that all models are wrong, but some are useful. Well, that's the case here. This model is definitely useful because it can, classify your users into categories to help the marketing campaigns target their users to sell their product. So this model is definitely useful, but it's wrong, of course, because there will always be some incorrect predictions. You will find some models with no incorrect predictions on the training set, but wait for it. When you test it on the test set, you will find always some incorrect predictions on new observations, which make them wrong. So that's what it is about. And now, as you can see, we can check the last ones just for fun. Okay, 111, 111, 00. Okay, one incorrect predictions on the 95th, but correct here and here. That looks fine. I can't wait to find out the number of incorrect predictions on the confusion matrix. So let's do this right now. Remember, we had 11 incorrect predictions with logistic regression. That will be our reference for comparison. So now let's see the number of incorrect predictions for SVM, kernel SVM. And so I just selected that, and we're going to find out right now. Command or Control plus Enter to execute. And here it is. Can we already see that? Yes, we can. It's actually right here. We have the 4 and the 3 here. So that means we have 7 incorrect predictions. Great. So better than logistic regression, definitely. 7 incorrect predictions on the test set. So that's an improved model, definitely. Let's click on OK. And now you can boil the water and prepare your coffee, or I don't know how you prepare your coffee, but you can get your coffee, because now what we only need to do is to select all this and visualize the training set results. So are you ready? Let's do this. You're going to see how our kernel SVM classifier manages to classify our categories and how it manages to catch those users and put them in the right category, those users that make our dataset non-linearly separable. So let's see, Command and Control plus Enter to execute. And here it is. Wow, beautiful, very beautiful. Let's enlarge this. Okay, so just for those of you who discover this plot for the first time, I'll just remind quickly what this is about. So all the points here are the observation points in our training set. So these are the users of our training set. And these are the true results. So all the points represent the truth, what really happened. Those red users didn't buy the SUV, and those green users, the green points here, bought the SUV. And then we have the regions, which are the prediction regions. So the red region here is the region where a classifier predicts that the user don't buy the SUV. So that means that any user falling in this region is predicted not to buy the SUV by the classifier. And the green region is the region where our classifier predicts that the user will buy the SUV, which means that any user falling in this region is predicted to buy the SUV according to the classifier. So that's the important thing to understand. The points are the truth and the regions are the predictions. And then the next thing to understand is that this separator here, separating the two regions, the green region and the red region, is called the prediction boundary. So before, with logistic regression and SVM with a linear kernel, we had a straight line separating the two categories. But here, since we jumped to a higher level, we built a nonlinear classifier, which we can clearly see here because the boundary is not a straight line anymore, but it's a curve, as you can see, that separates well the data. So now, definitely thanks to this classifier, these older users here with a low estimated salary are now classified in the right region. And same for this younger users with a high estimated salary, they are now well classified. And of course we have some incorrect predictions, which are, for example, here, here, or here. And that's because the kernel SVM is not like an overfitting classifier, like making a curve going all the way here and catching all the points here, doing this. That's because it's a sensible nonlinear classifier, but for example, if we play around and take a polynomial classifier with lots of degrees, you can choose the number of degrees in your parameters for kernel SVM. If you pick a polynomial kernel, well, you're going to see that it's going to be overfitting the dataset because it will try to catch also those green points here by doing multiple curves here. You can try and play around with that. It can actually be pretty fun. But the kernel SVM is a sensible classifier. And this is actually one of the best classifier you could find in that situation because you wouldn't want it to overfit your data because, okay, there is this green point here in the training set, but what does tell you that we will have the same green point in the test set? And last but not least, what I have to say is that, okay, we see this curve here that separates well the data, but don't forget that there was a terrific job at doing this because if you go behind the scenes, you can see that the kernel SVM jumped to a higher dimension to, find a higher dimensional space where it managed to distribute our data in such a way that the data was linearly separable in this higher dimensional space. And that is by using this mapping function that Kirill talked to you about, this mapping function that kind of take the data that was originally in a two-dimensional space into a three-dimensional space in which the data is now linearly separable. Then it found a linear boundary hyperplane in this higher dimensional space, that is the 3D dimensional space, and then it projected back to this two-dimensional space to finally obtain this curve here that separates well the data here. Okay, so that's it for the training set, and now let's look at the test set. So I'm going to close that, and then very efficiently select this, Command or Control plus Enter to execute, and here are the test set results. So let's enlarge this, and here we are. So wow, so yeah, that's great too. That's great results as well. We can clearly see that almost all our new observations are classified in the right category. The kernel SVM made a great deal of predictions, predicting that the users wouldn't buy the SUV in this red region and that they would buy the SUV in this green region. That's what happened. Of course, we have the incorrect predictions. Remember, we counted 7 incorrect predictions in the confusion matrix. So here we can count them. It's pretty quick. We have 1 here, 1, 2, 3, and 4, 5. These are the red truth observation points that are in the green predicted region. So these are incorrect predictions. So 4 and 5, and then 6, and finally 7. So yeah, there we are. We have our 7 incorrect predictions. But that's fine. I mean, as I told you during the training set part, that's totally fine. We don't want an overfitting classifier that classifies too well the data, and it's totally fine if we have some incorrect predictions. The marketing campaigns are not to the nearest dollar. So that's a good classifier, and now we can confirm that with this new observations results since it is well classified. Okay, so that's it. I strongly recommend you to play around with the parameters so that you can already try to improve yourself the models. And now I can't wait to show you the next classifiers, which will be the decision tree classifier and the random forest classifier. You're going to see that we're going to discover a brand new style of results. It's not going to be this kind of curve anymore. It will be something else. I won't tell you what it is and let you wait for the surprise. But that's what's so cool about machine learning, is that there is diversity in the models and the graphic results. We always discover some new things. And there is no limit to that. I mean, machine learning scientists and researchers are always thinking of new ideas of machine learning models, so you will always find some new tricks and some new innovative ideas about machine learning models. So that's what's so cool about machine learning. There is not a finite point. It's like the universe expanding to infinite limits. Okay, so thank you very much for watching this tutorial. I hope you liked the kernel SVM classifier. And now wait to see the decision tree and random forest classifier. That will be the subject of our next sections. Thank you for watching this tutorial. I look forward to seeing you in the next tutorials, and until